Exponents on whole numbers. Solve for the following. We have 4 raised to the second power. So this 4 is considered our base number, and then the number 2 is our exponent, where it goes. And really, exponents are just repeated multiplication. So what does that really mean? What this means is that this 2 is saying that there's 2 copies of 4 and they're being multiplied together. So we have 4 times 4, which is just equal to 16. So 4 raised to the second power is just 4 times 4, which is really 16. Now let's do another example. Example 2. Solve for the following. We have 6 raised to the 4th power. This time, it's saying that we have 4 copies of 6. So what this would look like is going 6 times 6 times 6 times 6. And the reason why we know there's 4 copies is because of that exponent. And we multiply whatever that is with the base number being multiplied. So we would go 6 times 6, and that would be 36. Then we have a 6 times 6 here, which that's 36. So now this is just becoming 36 times 36 to help kind of simplify it. So let's go ahead and write it over here. Now we have 6 times 6, which is 36. So put the 6 below, 3 is carried over. 6 times 3 is 18, plus 3 is 21. Then we have 0 as our placeholder. 3 times 6 is 18, so we put the 8 below, carry the 1. 3 times 3 is 9, plus 1 is 10. So put the 10 below. Now we just go ahead and add. 6 plus 0 is 6. 1 plus 8 is 9. 2 plus 0 is 2, and then we have just the 1. So we have 6 raised to the 4th power, which is 6 times 6 times 6 times 6, which is equal to 1,296. So this would be our actual solution here. Now let's do another example. Example 3. Solve for the following. We have 7 raised to the 3rd power. So our exponent is saying now we have 3 copies of 7, which is our base number, being multiplied together. So we know 7 times 7 is 49, and then we just need to multiply by 7. So we're going to go ahead and go 49 times 7. 9 times 7 is 63. 3, carry the 6. 4 times 7 is 28, plus 6 is 34. So we have 343, which is equivalent to the 7 raised to the 3rd power.